Hi everyone, this is a recording for Module 6 for the winter class on R for the Winter Institute. So my name is John Rochelli and I'll be going over some data manipulation today. Okay, let's get started. So far we've showed you how to read in some data, select specific rows with some indices, and maybe done a little bit of data exploration, looking at missing data or something like that. And now we're going to go over how to manipulate some of your data, summarize it, do some basic statistics and visualizations. So one thing you sometimes want to do with your data, just so you can get a better feel for it, is to sort the data, kind of just see what's small, what's large. And we want to go over sorting because it's a little different between sorting vectors, which we're going to use the sort command, and ordering, which we're going to use for data frames. So let's get started in R. Okay, so let's say we have this vector x, right? So we can see in our environment that x is in there. And so we have 1, 4, 7, 6, 4, 12, 9, 3. So if we sort x, it'll reorder x and show us the correct ordering for it. So the default in sort is to do it increasingly. So 1 is at the front, 12 is at the back. But if I print x again, note that nothing has changed in memory. If I wanted to create another vector that was the sorted version of x, I would say x.sort equals sort x. So I have to reassign it if I want it to save that sorted vector. Okay, now I want to show you order. So if I order x, right, one thing you should note, that ordering x does not return the values of x. Order returns a permutation which rearranges the first argument into ascending or descending order, right? So this tells you that if I were to take x, and I should put the first element in the first spot, I should take the 8th element, which actually if we look at x8, that is 3. If I took the 8th element and put it in the second spot, the second element, put it in the third spot, and so on and so forth, that would actually give me a sorted vector. So for example, if I do x order x, right, this is saying, tell me how I have to shift the indices in order to get x to be ordered, and that will return a sorted vector. Maybe a little bit easier to show you if x is from -5 to 0, right? So then they're negative, right? So now we know they're negative, so let's do order x, where 1, 2, 3, 4, 5, 6. We already know they're in order. Let's do something a little more, maybe not sophisticated, but so that it has to actually do some ordering, and we'll actually put a positive value in there. So x. Okay, so now we have these values, and if we say order x, right? So order x is saying that -5, which is in the first spot, if we just kept it there, it's fine. Now it's saying if you put whatever was in x that was in the 4th spot, which is -2, into the second slot, or then that will order x. That will sort x accordingly. So again, let's say x order x. So one thing we should note: sort x returns the vector in a sorted fashion. Order tells you how would I have to shuffle around the indices in order to get a sorted vector. And these both take in optional arguments of decreasing equals false, or decreasing, so you can say that to be true. So instead of sorting 1, 2, 3, 4, 5, 6, 7, you could sort it decreasing equals true. So let's say sort x, decreasing equals true, and it'll go in the opposite direction. Start with the highest first. Note, let's say x5 equals NA. So if there's missing data, it actually doesn't return the NA at all. And if we go to the help file, so remember the question mark will allow you to look at the help file. So again, NA.last is an argument for controlling the treatment of NAs. If it's true, missing values in the data are put last. If false, they're put first. NA if they're removed. And for sort, NA.last equals NA, which means by default it removes the NA. Let's see what happens with order. Order surprisingly has a different default. So if I say order X, and if I say X order X, that's actually going to put NAs at the last. So we could get the same result if we say sort X NA dot last equals true. Okay? So hopefully that, I know it's a little bit strange why you would ever use ordered, but this will make a lot more sense when you have a data frame. Okay, so let's read in this data frame. So this is the Charm City circulator data. Okay, and I'm just going to put, and we're just going to take only a few. So let's say col names dat, right? Or we can say str for the structure of dat, and it'll tell us the day, the date, the orange line, all that kind of stuff. And dat2, we just actually subsetted the specific columns. So technically, we kept all of the columns, right? So these are actually all the columns. Why would we do this in practice? Because if you have a data set, for example, that's a CSV that maybe somebody's updating or changing and the column names might change or something like that, or you might add columns and you only want a specific set of them, this might be a reason why you would do this. Okay. So, again, when we say the $sign, we're taking the daily ridership. That's what the daily column is. So if I say head dat2, right? So this is saying the average daily ridership for all of the lines on the circulator in Baltimore. So if you don't know, the circulator is a bus that goes around the city, and there's the orange, the purple, the green, the banner lines. So if we say order it, it gives us indices that if I said shuffle the indices to put the 888th record first, then it would sort it correctly, right? So if we actually look at that, sorry, not first, because we put decreasing equals true. So 888, the 888th record in this vector is actually the largest average ridership. Okay? So that's great for vectors, but that's kind of an overview of what we've already done. So let's see what if we say sort dat2. Sort does not work on a data frame, right? So we cannot just say sort and it'll sort the entire data frame. What we actually want to do is we want to sort the data frame by a set of columns. If those of you who know Stata or SAS, you know this doesn't really make sense if you just say sort, right? Because you usually have to sort by variables, and by variables I mean columns in that matrix, in that data frame, in that data set. So usually a lot of times you want to sort by patient and then maybe visit, for example, if you have longitudinal data. So here's an example where we actually create a new data frame, right? We say dat2, we order it, decreasing equals true, and call it dat sorted. So I'm going to show you the first 5 rows of that. Now note, when you order things, you are reordering the rows, right? So if you think of a data frame where the rows are the observations and the columns are the variables or the covariates, if you think of that in a modeling framework, then you order the rows. You shuffle the rows around so that they are ordered vertically, right? So here we're saying we want to order the daily ridership and we want it to be decreasing, so the highest is first, and we're looking at this here. So now if we look at this, like I said before, the 888th row of dat2 actually has the highest average ridership. So that date was June 16th, 2012. So this is a way to allow you to sort a data frame on a variable, but then actually see another variable. So for example, if I were to ask you, on what date is the second highest ridership, you know that I can say dat sorted, and I can say date, right? I hit tab so I can get some completion, and I can say 2. So that'll give us the date for the second highest average daily ridership. Now there is a little bit of technical things. What happens when you have ties? Sometimes it randomly shuffles them, so you can look at the help file for that, but a lot of times it doesn't really matter, especially when you're sorting on something that's a continuous variable here that you're not very likely to have ties, and it's not a really big deal if many times you don't want the second or third, you want the top, and sometimes it could be problematic if the top actually is tied. Okay, so like we said before, when you create a data frame from a subset of another data frame, the row names actually correspond to the original data frame. So for example, data sorted, This row number 888 actually says that this was the 888th row from DAT 2. But a lot of times that data isn't really relevant, right? So we want to just clear that out. So what we do is we take the command row names and we set it to be null. I know in day one I said for the majority of things you usually don't have functions on the left side, but row names and column names are a little bit different. So things that are attributes, things that are kind of about the data frame, but aren't necessarily data, so the row names and the column names are just kind of labels in some respects, then you can do this kind of assignment. So if you look at the help file and it's got this type of syntax where you have the function on the left-hand side and it's got an assignment operator, that's what we call that, either the less than and then the hyphen or the equal sign, then you can actually assign things using the function on the left-hand side. So this just says null means I want to clear out all the row names. So let's do this again. Let's show the first 5 rows. So the one thing about a data frame is it needs to have row names. It needs to have them. That's one of the requirements of this object. So what it'll do is when you say null, it'll actually remove all the old ones and it'll actually just put 1 to the number of rows in the data frame. So if I say row names dot sorted, it's just going to be 1, 2, 3, 4, 5, 6, 7, but they'll all be strings. So that's the equivalent of saying 1 to n row dot sorted. Right? I could do this, row names dot sorted. Right? So if we just do the top 5 again, it's the exact same thing. But in some applications, the row names actually really matter. They might have a patient identifier on there or some sort of information that's actually relevant. In some of the genomic work that Andrew does, the gene names, for example, are actually in the rows. Okay, so I'm going to clear my console really quickly. All right, so that gets a little bit to how you would sort a vector. So for example, if you want to sort by multiple things, right? So let's say dat 3, I want to order by the purple average, and then I want to do by the green average, and then by the orange average, right? Remember, head will just give you the first 3 rows. So we see sorted by the purple averages, so we see there's 0, the green average, which is zeros, and then the orange average. So we see this obviously, this should have the lowest number in there because this should be, because by default it says decreasing equals false, so it should start with the lowest and then go to the highest. And so now we sorted by these 3 variables. Now what happens if you want to sort ascending, right? So or increasing, for example, where you want it to be this is the lowest, and of these being the lowest, this is the highest. So you actually would write a negative, right? So if you sort the negative of something, that'll switch the directions. So if you sorted something in an increasing direction and then put a negative on it, it would switch the way it was sorted. So that's the way where you can get this sorted positively, sorted negatively. That's the way I kind of would refer to it. Or sort this increasingly, sort this decreasingly, and sort this increasingly, right? That changes if you then change the default, but this is a way where you can actually sort by multiple variables in different ways, right? If you use stata, this is equivalent to gsort, right? Gsort will allow you to sort things in different directions. Okay, so hopefully that gives you an idea of how to sort data frames. So again, whenever we're talking about sorting a data frame, we're talking about using the command or the function order. So just to be clear, whenever I say command, I interchange that with the term function. Pretty much anything that takes an input and output and everything else in the middle is parentheses. Okay? Now, a lot of times we want to create categorical variables, right? So this is ubiquitous in all of epidemiological research. So examples are gender, race, marital status, something that actually has categories that isn't a continuous variable and not a binary variable. This is an example of a binary variable, but we want to code it in a certain way. So this is going to introduce, in some respects, what we're calling factors. Okay, so I'm going to create a very easy vector called BG, and it just stands for boy, girl. So I'm introducing the rep command, or the replicate. Let's just look a little bit at that help file. Replicate elements of vectors and lists. Or you can also think of it as repeat. But just to be clear, there's a repeat function that is not at all. Sorry about that. So if you ever do a question mark and it gives you the plus, that means it's waiting for more conditions. So sometimes there are very special commands in R, like the for loop, the while loop, the if statements, and stuff like that, which we'll get to a little bit later, that actually it assumes you want to put some more stuff in. So if you ever get the plus sign here, that just means R is waiting for more from you. So if you hit escape or Control C or Command C, depending on if you're Mac or Windows, you can just use the help command and you can just say repeat. And that is a little bit, I would say, more robust, more not likely to result in this thing where R wants more from you. Okay, so I'm saying there is another command called repeat, and that's not what we're talking about. We're talking about rep. So replicate. So what does this do? I want to replicate boy, girl, each of them 50 times. So if I do table BG, it'll show us that that BG vector actually is 50 statements of boy, 50 statements of girl. Okay. What that'll do, when you say each, it'll say the first element each number of times. So in this case, each number of times is 50. So it'll put boy 50 times, and then it'll put girl 50 times. Okay. There is a different way where you can repeat, where you say replicate times equals 50. Now you see, let's see, head BG2. Okay. So you can see, if you say each equals 50, then it puts 50 of the first element, then 50 of the next element. If you say times equals 50, it actually will do first element, second element, first element, second element, over and over and over again. And if I put other, right, then we'll just do boy, girl, other, da, 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 da. All right, and so it'll repeat this vector 50 times. All right, so I'm going to take that out, because the statement down here. All right, so I'm going to rerun that. So length BG equals length BG2. So remember, equals does not mean I'm assigning anything. Equals is a logical operator saying, is the length of this vector equal to the length of this vector, right? And they should be true, right? Because this just repeats boy 50 times, then girls 50 times, whereas BG2 replicates boy, then girl, and it does that 50 times. So each of them should have, length of 100. Okay? All right. This is really important when, for example, if you have data sorted by the treatment variable, right? So you could see that if for some reason the way you structured your Excel file or something like that, that the first X cases were boys, or in this case untreated, whereas the second 50 cases were treated, then this would be a way to actually create a vector that you could add to a data frame that would actually allow you to add that on there. So let me say one more thing. If you want to create things of different lengths, so let's say boy, and I want to repeat this 25 times, and I want to repeat girl 10 times. Oops, let's call this BG3. So we see that this vector, so okay, let's go back to rep. So by default, when you say rep, it assumes you're doing this kind of way. You say, how many times do you want this? No each or anything like that. But when you only pass one thing, they're equivalent. It doesn't really matter. But BG3, so this says, I want to repeat boy 25 times, and then after all I repeated boy 25 times, I want to repeat girl 10 times. Okay, great. So that is kind of an ugly way to do it, right? Because you have to put this combine, this combine or concatenate function around it. It's like, I don't want to do that. So can we just do it in one simple command? So no, that's the problem, is that you have to kind of do it this way, is that rep really only takes one argument for each. It doesn't take a vector, so you can only do it this ugly way. But this ugly way is important when you want things of different sizes. Okay? Alrighty. So, great. Alright. Okay, so we're going to be talking about if-else statements again. Or, I guess for the first time. So, what I want to talk about is an if-else statement, which takes in a logical test. Right, so let's go to your module 6. So it takes in a logical test, and whatever that test comes up true, it'll put in the yes category. Whatever comes up false, it'll put in the no category. And whatever it puts an NA, it'll return it as an NA. So, okay. So this says, what does this statement say? This says, is the daily ridership greater than 10,000? And if it is, put a 1. If it's not, put a 0. Okay? So, and then we do a little bit of table here, and then I put a little bit of statement here, an option here to use NA if any. So this now says the high rider vector is just 1 if the daily ridership is greater than 10,000. It's 0 if it's less than or equal to 10,000, and the NAs stay as NAs. Right? So this isn't a super fancy or super exciting result, because if we just did that daily ridership is greater than 10,000, we actually would just get a logical vector that's just almost the same thing. Right? So logical vectors, right, instead of table. Oops. Right, so if we table high rider and we table the daily over 10,000, just this one logical statement, we get essentially the same thing, except high rider has 0 where we'd have false, and we'd have 1 in high rider where we'd actually have true. So if-else statements are actually very important, though this statement doesn't exactly show that. We want to just show you a very, very simple case. So if we wanted, for example, the NAs to come out as something else other than NA, we could do a few things, right? We could say dat daily ridership is greater than 10,000, or is dot NA dat daily. So that's going to say, for an NA value, is the ridership greater than 10,000? It's going to come up NA. And then it's going to say, or is the, so this is a function, is dot NA, is the daily ridership an NA? So this will come up true for NAs. And when you say anything or a true, it'll always come up true. So if you have a false or true, it comes up true. A true or true, it comes up true. An NA or true, it comes up true. Let's say NA or true. Let's say false or true. Obviously true or true is true. So this is just a little bit of a refresher of your logic, where is false true and true true is something you might have considered before, but this is something that's very important. NA or true is always true, and NA and false is always false, right? So if you say something is false, whatever you end that with, it doesn't matter. It could be a true, false and true. It's going to be false, right? So you can think of this as, if these are zeros and these are ones, then you kind of think of it as multiplication. 0 times 1 is always 0, 1 or 0, and kind of think of this as addition. 1 plus 0 is always greater than 0, 1 plus 1 is always greater than 0, but it's a little bit different when you actually think of this as addition. So I just want to go over these logic rules a little bit. Okay, anyway, so that if-else statement wasn't super exciting, but we can do compound if statements, right, or if-else statements. So now we can say, if-else, that daily rider is less than 10,000, call it low, put the value of low there, and then what happens when that's false? That means the daily ridership is greater than or equal to 10,000. So again, let's see x, so let's say x is 1, 2, 3, 4, 5. If I say x is less than 3, the opposite of that is x is greater than or equal to 3. Right, so if if you look at that should be clear. So that the opposite of a less than is a greater than or equal to, the opposite of a greater than is less than or equal to, and so on and so forth. So, also I just want to refresh, if we ever want to take the negative of a statement, so if I say head is.na.daily, what you're saying is the daily ridership NA? Is it missing? The way we can invert that or negate that, where we turn all the trues to falses, all the falses to trues, the NAs to NA, you can do what's called a bang or an exclamation point. So in Stata or in SAS, I know you use the tilde. I believe not equal to is also something that you can do, I believe, in Stata. So this bang or exclamation point should be somewhat known to those of you at least who know Stata a little bit. So anyway, so what do we got here? So this if-else statement says, is your daily ridership less than 10,000? We'll call it a low. If it's greater than or equal to 10,000, then come to this statement. If it's greater than 20,000, we'll call it high. Otherwise, we'll call it medium, which means high is above 20,000, low is less than 10,000, and medium is anything in between. And NAs, again, remain NA. So if I say table use NA equals if any, then the NAs remain like that. Okay, great. So we got a little bit about if-else statements. Now, this is really important, right? Because in that last setting, we wanted to create, a categorical variable that is high, medium, and low. All right. So now we're also going to create what's called categorical variables using what we call cut. So cut divides the range of x into intervals and codes the values in x according to which interval they fall. Right. So this you can think of having. So we're going to show you maybe just showing you examples a little bit better, but I want to go over the arguments. So x is a numeric variable that's to be converted. Breaks is either a numeric variable saying these are the breakpoints I want to use, or we use a single number to say how many breaks do you want. Okay. Labels for the levels of the resulting category, which means when you cut all these things up, it's going to say this is level 1, this is level 2, this is level 3, so on and so forth. And what it does, I'll show you in a minute, is they use this left-right notation of intervals. So if you remember the number line, and left means everything up into that point, but, the percent means not including that value, but everything up into that, and the bracket means including that variable. So for example, 0, 1 means 0.00001 is in this interval, but 0 is not, and 0.9999999 is in this interval, and 1 is also in this interval because the bracket means include it, the parenthesis means everything up into this, but not this value. Okay. But you usually want to keep the labels on, but there is a way you can say labels equals false. So let's see, for example, I'm going to create, don't worry about this command, but I'm just going to create a bunch of continuous variables. X equals. So it just means I want to create random uniform variables that are randomly distributed variables that have a uniform distribution. Don't worry about it. It's just saying I want to create something continuous so I can show you something. So I want to cut X, and I want to say breaks equals 2. So what this will do is this will break X into 2 different things. So note, this does not do quantile-based cutting, right? So if you wanted it cut on the median, for example, I'll show you a little bit later in the lecture how to do that, but this cuts it at different breakpoints. And you can look at cut to see exactly how it does that. And you can see this very, very important thing here called include dot lowest equals false. So include dot lowest equals true. I have to put that in the cut statement. Right? So here it doesn't really matter, right? Because the breakpoints actually go outside. So if I say range of X, which gives me obviously the range, right? It actually tells me what the range of the data is. It actually gives me the min and the max. If I say min x, max x, it actually gives me the min and the max. But cut, when the difference between these two is this bracket right here, which is very important because if you actually had a value that was exactly that, for example, then it wouldn't be included with this, it would be included with this. So include.lowest says if a breakpoint, right, actually pushes up right against this, then you should include it. This isn't so important for continuous variables, but it is very important for non-continuous or discrete variables. Okay, so you see when I did this table, you see levels, or did this cut, you see levels. So what does that mean? Whenever you see a vector and you print it out and it says levels, that means this is called a factor. Factors are the equivalent of categorical variables in R. So sometimes in SAS and Stata, you can have like gender or marital status or something that's discrete and has levels or categories, and you can actually label them with something. That is essentially what R sees, right? So in Stata, for example, you might call white, African American, and Asian or Pacific Islander to be 0, 1, 2, for example, with race. And you might label them with those labels so you can actually know what they are. Whereas if you made, let's see, so white, let's say white, 3. So in our sample, let's say there were people who identified as white. Let's say there were 4 people, or 5 who identified as Asian, Pacific, Islander, right? And those happen to be the only types of things you saw, right? So now that's just a character vector. Again, you can see the difference when I say factor, that they don't put quotes around things, and they also put this level statement. So just to be clear that when you see this, these mean that the class of X are very different. One's a character, one is a factor. Okay, so what does the function factor actually take into? So it takes in usually a character vector, it takes in levels, it takes in labels for those levels, it says what you're supposed to be doing with excluding, and asks whether the vector should be ordered, right? This is kind of not, you usually don't have ordered factors in a lot of settings. Maybe high, medium, and low is an example of an ordered factor, but for the majority of functions, the ordering doesn't matter other than, there's ordered logistic regression and stuff like that. They're very important, right, for a reference category. But let's not talk about ordered right now, but what do you do with levels? Okay. So factor X, it automatically does, which we talked about in class, alphanumeric sorting, so alphabetical sorting for your factors, right? So if I say labels, so what happened? I pass in a vector of white, African American, Asian, or Pacific Islander, but I actually labeled it something completely different, right? So if I say factor X, African American, Asian, Pacific Islander, sorry, I misspelled Pacific very badly. There should be an I there. And then white are the levels that it automatically assigns. But what if I wanted, for example, the levels? I wanted white as my reference. African American. I want to show. So I'll show you what they're doing, and then I'm just going to copy and paste this because I spelled it. Okay, now you see the difference. You see African American was first. Now white is first with respect to the levels of the variable. Right, so it's an X factor. All right. So if I say levels, which is another function, it allows you to pick off the levels of that factor. Say, what is the first level, what is the second level, what is the third level? right? But if you can use table and everything works fine, it does the tabling. But note that if I say table X, it will do the ordering alphabetically if I just do it on X, which is, again, is a character. But if I do it on a factor, it'll put my factors in order in the table, which is nice, right? Because a lot of times when you're doing table 1 or something like that, you want things in a specific order. So great, factors. And one of the very, very common ones in epidemiology is case control studies, right? So one of the problems with that is if you factor case and control, case always comes first alphabetically, right? Maybe if we had started out with R, we had named these a little bit different or something like that. But so you can do a few different things to get them in the order of control or case. So let's do this. Let's say CC. Okay. Let's say levels CC. So we want control to be the first level. Now, one of two things we can say levels equals, again, this is one of those cases where you can actually put functions on the left-hand side. And if I say levels, it will show you that you can do an assignment here, right? Okay, levels, CC, control and case, great. Now, we could have done it from the start and just said that the levels are control. Oh, I think we just got that code down here. And we can just do it from the start and say levels equals control case, right? And so now we see automatically that the control is the first level. We can also say ordered equals true, and ordered, you see this little less than sign, which shows you that it's an ordered factor, right? But case and control, you don't necessarily order them. Doesn't really matter. But one thing that we do talk about in the lecture notes that's very, very important. When you read things in the R with read.table, you see that there is a statement called strings as factors. So if you had names or gender or something like that, then by default, this default.strings factors, right? You can actually see what that is. It's true. So by default, it actually always converts them to factors, which is usually not what you want to do. Because, for example, if you had names or something in there, which I argue you should not have names in de-identified data, but anyway, then it would be a problem because you'd actually have all the names as different levels of factors. So you usually want to say there's an as.is, or you just put this to be false. Anyway, so one very important thing. X is this in cases of controls. If you say as.character, it'll just return them back, right? It'll actually take the labels and it'll actually put them as character strings, which is great. You can also do as.numeric. As.numeric actually takes things that might be numeric or not and converts them to a numeric vector. So actually what you want to do, what you actually see here is what it will put in here when you say as.numeric on a factor. It'll put a number for which level that is. So you see here, case is level 2, so it puts a 2. Control is level 1, so it puts a 1. Now, this is problematic because if you did something like this, 1, 3, 2, right? The levels are 1, 2, 3, so that's all fine. What happens? 5. So X. If I say factor X, the levels are 1, 2, 5. Great. I can still see that they're 1, 2, 5, right? And if I see as.character X, they come out as the character versions of them, but I can still see that they're 1, 2, 5. What happens if I do as.numeric? Do you think it'll come out as 1, 2, 5? You would think, but it does not, because the way it does it. It says that 1 is the first level, so it's 5. So maybe let's do this. Let's do 6, 5, 4. This is a better example. So the levels are 4, 5, 6. If I say as.numeric, it actually does 3, 2, 1. Those aren't any of the numbers I had in there. What it actually does, remember, is it says what is 6? It is level 3, so I'm going to put a 3. What is 5? 5 is level 2, so I'm going to put a 2. What is 6? Level 1. What is 6? Level 3, so I'll put a 3. So this 3 corresponds to this in the factor was this label number. So the way you convert from a numeric factor that you didn't actually want it to be a factor, so you have to go first through this character, right? So you add that character x, and then you say as that numeric on that. So it's a little convoluted, but that's the way you do it. And if you don't know, sorry, not if you don't know, but if you aren't careful, then things can get a little bit strange. All right. So we're going to go through a couple examples of cut. So, okay, let's make 0 to 100, or 1 to 100, so x is on vector 1 to 100. We're going to cut x, and we see that cutting x gives us these nice little levels, right? We can actually leave off the labels, right? So what it'll do, instead of writing these labels saying this is 50 to 100, it actually just makes 1, 2, 3, 4, right? So this cx, right? So as we've been kind of talking about over and over again, this is level 1, so it has a 1. This is level 2, so it has a 2, so on and so forth. Okay. So, but if you actually put the breaks, then you have to specify the endpoints of the data, otherwise some of the categories won't be created. So we know if we put this, we know that there are values outside of 50 and lower than 10. So you actually don't put those into any category. So you have to make sure that if you're specifying the breaks, that you actually know what's kind of going on. So here we're going to do the routing levels where we actually do 0 to 10,000, 20,000, 100,000. And we actually see that there still are some NAs, and we can see, so we can say sum is.NA that to rider levels and is.NA that to daily, right? So this will actually tell us these are 124 cases where the rider levels is NA, so that's 124 out of this 133. And the original data was NA. So there's actually, right, 133 minus this. There's 9 of them that are actually categorized as NA, even though the original data was NA, because it was greater than 100,000. So that's the same thing as that 2 daily is greater than 100,000. Oh, sorry. That's actually not the case. It is actually because the 0 is non-inclusive, right? So if we didn't put the lowest factor, so we have these 9 cases, because again, you see this doesn't include it, so we want to say include.lowest equals true. Then it actually takes these 9 cases that are actually all 0 and puts them in there. Okay. So again, you can take this cut variable and assign it a new column, and we see that it just gets added. So we're just making matrices here, but we want to talk about something very, very quickly. So let's make these little matrices, M1 and M2. Right? So, the one thing I want to show you is that when you make a matrix, by default, we talked about that it goes by columns. So it takes 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And by default, by row equals false. You can have it fill in the matrix by rows just by setting the by row equals true. So you can see that these are different in the sense M2, you went 1, 2, 3, then 4, 5, 6, then 7, 8, 9. So that all depends on how you want to do it. But we really want to talk about the C bind, which means column bind. Right? And R bind, which means row bind. So C bind will take the columns of M1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and concatenate the columns with M2. Right? And you can see the difference between that and R bind. Right? So with data frames and stuff like that, you can either do like we did before. We actually say that to rider levels equals something, right? So that actually equals this thing. Or you can make a new variable, or if you have a new vector that's actually the same length, then you can C-bind it to that. And that C-binding will take the data frame, add the column that you want, and that, excuse me, and that actually will give you what you need, right? If you did R-bind, it wouldn't be correct, but remember, it goes in the order that things were processed. So because you put the data frame first, it's going to add this to the end. If you did, for example, that 3, so let me put this. So also, sorry, note that if you C-bind something and you don't say what it's equal to, then it's going to call that column name whatever the name of the vector is. So if you say C-bind rider levels, so if I say that to rider equals null, we got rid of that. And okay, so that's gone now. But let's say we want to C-bind it again. So you can actually specify the name of the column, just saying name of column equals vector. Okay, so hopefully that gets you a little bit into data manipulation of your rows and columns. We also talk about a couple other functions that you can use. So I went through some of, maybe not some of these. These are just all like mathematical manipulations, like rounding, significant digits, cosine, stuff like that. All right, thank you, and I hope you guys have enjoyed.